Welcome back everyone. Today is the Q&A session 6 from the chapter of wave optics and the topic is apparent depth. So this session is in continuation of the session number 5. So in the session number 5 we have derived one equation that is mu 2 divided by capital H was equal to mu 1 divided by small h, where capital H was the real depth of an object and this small h was the apparent depth. Now here I have made one small figure in order to revise what we have studied in the session number 5, and so here I have taken one tank. This is a tank which is filled with water, and I have taken the absolute refractive index of this medium as mu2, and there is a person who is viewing this tank from the top, and the medium outside this tank is air, and this air is having the absolute refractive index of mu1. Now this person finds now there is an object which is lying at the bottom of this tank, and I have denoted its position by capital O. So the person will find this object to be raised by a certain height, and here I have denoted the virtual, or you can say the apparent depth of this object as C, where this AC is the apparent depth, which is equal to small h, and AO is the real depth of this object, which is denoted by capital H. So considering this example, the formula for getting or finding the this apparent depth is given by mu2 upon capital H is equal to mu1 upon small h, where h capital H is the real depth of this object and small h is the apparent depth of this object. Mu2 is the absolute refractive index of the medium in which it is kept, and mu1 is the absolute refractive index of the medium from where that person is seeing this object. So from this now I will be using this formula in order to find the solution of this question. Now here the question is, a vessel contains a glass slab and water as shown in this figure. Find the apparent depth and the apparent shape of the object which is placed at the bottom of this vessel. So here I have, so this is the figure which was given along with this with the question. So here you can see that a glass slab is placed at the bottom of this vessel, and above it is the water which is having an absolute refractive index of 4/3. Glass is having an absolute refractive index of 1.5. So this is the object, and we have to find the apparent depth and the apparent shape of this object which is placed at the bottom of this vessel. So now if I use this formula, then for the apparent depth due to the glass medium, we can we can use this equation, and we will arrive at here mu2 is equal to 1.5. H is the real depth of this object, so this is equal to 10. Mu1 is here, the mu1 will be, see, we are perceiving this object from air, means there is a person who is seeing this object from the top, and this medium is air. So here the mu1 will be the absolute refractive index of air, so which is equal to 1 divided by h. So it implies that H will be equal to 10 divided by 1.5, and this will be equal to 100 divided by 15. It can be written as if I divide it by 5, that is equal to 20 by 3 centimeter. So this is the apparent depth due to this glass medium, and I will just write this as the apparent depth due to the glass. So I am just writing it as Hg. So here Hg, that is the apparent depth of this object due to this glass medium, is equal to 20 by 3 centimeter. So this will be equal to 6.67 centimeter. Now, considering this medium, that is water. So here the absolute refractive index of water is 4 by 3, and so if I am considering this medium, so I will be using this formula again. So in this case, that is for calculating the apparent depth, due to water, if I use this formula, then I will be getting mu2 is equal to 4 by 3 divided by capital H. H is equal to 50 centimeter, and divided by 1, it is mu1 divided by H. And I am writing this H as HW, because this is the for the apparent because this is the apparent depth due to this this water medium. So it implies that HW will be equal to 150 divided by 4, which is equal to 37.5 centimeter. Okay, now so I have found the apparent depth of this object due to this glass medium, which was equal to 6.67 centimeter, and I have also found the apparent depth of this object due to this water. So this is equal to 37.5 centimeters. So the the apparent depth of the object will be equal to, it will be equal to Hg, that is the apparent depth due to the glass medium, plus the apparent depth due to the water medium. So this is equal to 6.67 centimeter plus 37.5 centimeter, which is equal to, if I just add it, this is equal to 7, and 5 and 6 is equal to 11, so 1, and this is equal to sorry, if I just added, that is, this is equal to 6.67 here, so this is equal to 7, 14, yeah. So this is the answer. That is, the apparent depth of the object due to this glass and water will be equal to 44.17 centimeter. Now I have to calculate the apparent shift also. So apparent shift is basically, the apparent shift is equal to, the formula for the apparent shift is equal to real depth minus apparent depth. So this will be equal to the real depth is equal to how much? 50 plus 10, that is equal to 60 centimeter, and the apparent depth was equal to 44.17 centimeter. So this will be equal to what? This will be equal to 60.00, that is equal to minus 44.17. So this will be equal to 9 minus 1, that is equal to 8, and this is equal to uh, uh, okay, this is equal to 15.83 centimeter. Okay, this is 3 and 8, and this is equal to, yeah. So the apparent shift is equal to, which is equal to real depth minus apparent depth, that, so this is equal to 60 minus 44.7, that is equal to 15.83 centimeter. And the apparent depth of the object is due to this glass medium and this water medium. So the apparent depth due to the glass was equal to 6.67 centimeter, and the apparent depth due to this water medium was equal to 27.5 centimeter. So adding up, the apparent depth of this object is equal to 44.17 centimeter, and the apparent shift is equal to real depth minus apparent depth. So this is equal to 15.83 centimeter. Now this apparent shift basically is, see, the apparent depth of the object is equal to 44.17 centimeter. It means that this object will be perceived by the person who is seeing this from the top. He will perceive this object at a depth of 44.17 centimeter from the top. That is from this surface. So if now this is 44.17 centimeters, so the depth of this water is 50 centimeters. So somewhere here he will be perceiving this object, and which will be this somewhere here. Means he will be perceiving this object in this water medium, and this is equal to 44.17 centimeter, and the shift will be equal to, this is the shift, that is the difference between the real depth and the apparent depth. So this is the shift, which is equal to 15.83 centimeter. So this is so in this way we are supposed to solve this question. So here the most important formula was that we have to use the formula, that is mu2 upon h was equal to mu1 upon small h, where capital H is the real depth of the object, h is the apparent depth of that object, mu2 is the medium of this is a medium, mu2 is the absolute refractive index of the mu2 is the absolute refractive index of this glass medium, and mu1 will be the absolute refractive index of the medium from where we are perceiving this object. So in this case, mu1 will be the absolute refractive index of air, mu2 is the absolute this refractive index of glass, and mu2 is also the refractive index. That is, in one case, when we are taking the combination of glass and air, then mu2 is the absolute refractive index of glass, and mu1 is the absolute refractive index of air. And when we are taking the case of water, then mu2 will be equal to the absolute refractive index of water, and mu1 will be the absolute refractive index of air. So thank you very much for joining this session, and in the next session I will be continuing with with a different type of a question, but it will be based on the same topic. So till then, have a nice day. Bye.